I want your imagination to flow. I want your thinking to go out of this conventional, canonical teaching. I want you to think differently. That's why I brought this stone to tell you that this will be an intercalator-like molecule. A nucleic acid will be a target. So therefore, the biggest problem is, if I take this and start doing, what happens? You see, that is more like the stone, right? One orientation it may bind, in another orientation it will bind to non-target. So I need specificity. So in the process, you are go on designing smaller and smaller molecule, but it is impossible to have a molecule which does not have a complementary surface or a shape or a charge, where something else can go and bind. Until we know all the structures of all the proteins in the human body, and so therefore, किधर चल गए था ना? This one. I just made mistake. Yeah. So all of us have focused all these years in the active site. I'm saying let's not focus on active site. Active sites are nothing but proton donor, proton acceptor, hydroxyl group, कुछ नहीं होगा. वो सब phosphatase looks similar. You know, I have a big fight with my daughter whenever I said, you know, all your friends look alike. She said, why? I said, all of you wear some blue jeans and some sort of dark t-shirt. So I can't figure out in a crowd, where are you? So same problem. The more uniformity, all active sites are very similar chemical function. Therefore, can we find a site which is non-active site, but binding there will actually collapse the active site? That's a new hypothesis. So if you take a stapler, I don't have a stapler here, I forgot. If you have a stapler, then again, this is the binding site. This is the active site. Different stapler. You go to stapler.com, you will see hundreds of staplers. Okay, there is a stapler.com. You can go and see. Okay? But if I put one chalk here, khatam, no? Irrespective of the size of the stapler, you are gone. So therefore, non-active site should be our target. And that's the model is telling you, Achilles' heel is to decide the structural determinant. Now how did it come? Let's say you have to collapse this building. Don't tell to principal, but I'm just saying as an example. You blow, you can change the window, change the door, change this, make it look ultra-modern, flooring, everything. Although wonderful flooring you have, but you can change everything. But you cannot change two things. Look at the structure. There is an engineering pillar, I'm sure somewhere, which is holding the structure. Correct? And there are some columns. Beautiful engineering. Right? You are not seeing obviously a structure. But those are very innovative structures. So if you break those, whole thing will collapse. You can't change. So can we find those Achilles' heel? You know Achilles' heel? Achilles? He had a weakness here. Why? He was held like this and dipped. That's right. The same thing as the Duryodhan Janu. So therefore, it is this. You have to find the protein target. So what did I do? Again, you do the same exercise. Look at the potential target. Let me just finish my talk by telling that what pained me to do this. I was very naive. I never done any drug discovery. I suddenly felt it is important that we worry about tuberculosis. So all my bioinformatics resources we put in, and 2002-03 we discovered 69 new targets. We took patents in tuberculosis. Went to AstraZeneca, went to Pfizer, went to others, but nobody was interested. They all said, there's no market. And this idea was based on this principle, which eventually I patented and then published. Then that brought me to the pain that even if a new idea comes, pharma companies will not pick it up. So it is our job to take it forward. And therefore, so the idea is that you should make sure the protein that you are targeting is absent in human gut flora, absent in your mouth flora, absent everywhere. And that's the one you target.